Hello everyone, I am Shashank and welcome to my channel. And today in this video, I'm going to talk about media handling service. So basically, all the services like YouTube, LinkedIn, Instagram, which we use, and there most of the time we upload media files. On Instagram, we are uploading images, videos, reels, and then we are constantly consuming it. On YouTube, we upload large size of media files. On LinkedIn also we post a lot of pictures. We lot of times we upload like PDF files. So in this video we will try to understand that how all of this media files, how all of these media files are handled properly and how they are served from our backend system. So we will have a walkthrough of the entire journey of this media file from the client side, and then landing to the backend and then finally serving to like millions of users. So we'll go deeper into how this media handling service is designed and what are the things we should keep in mind when we are working with media files. Okay, so let's quickly go into uh, the basically topic, and that is media uploads. So basically, in this video, we are going to discuss about how to allow uploading media files from client to server, not just images, but videos, PDF files, any kind of media file that we will learn how to upload it from the client side to the server side, and how to store these media files, because there are some special media files where to store them, and then how to serve these media files once they are stored somewhere. Okay, so take an example of this video. I'm creating this content for YouTube. Okay, I'm using some camera setup. I'm recording my screen. I'm like creating content for YouTube, and then I'll upload this content on YouTube. So I expect some good quality user experience from YouTube, that it allows me to upload large size of media files without any interruption. And once it is uploaded, my subscribers should be able to see this video file in good quality. Okay, because I've put a lot of work creating this video, so I expect YouTube to give me a good quality. So as an engineer, how like I can make sure that if my users are uploading media files, where we are storing them, how we are serving them once they are stored, how we are processing them. All of these things we should think about as engineers when we want to have when we want to build a good user experience for such systems where we are dealing with media files. Okay, so these are the use cases. And even like for a small app these days, this fairly simple use case is always there, where a user can upload their profile picture. Okay, clicking some upload picture button. So how all of this works behind the scene, and as engineers, how we can design such systems. Let us look into that topic. Okay, so this is the overall architecture of a media handling service, and we'll go into this one by one. We will look into all the components, the entire process. Okay, so let me just give you first like a walkthrough of all the components we have here in place. First, we have a client, and a client is nothing but it can be a website, it can be a mobile application, desktop application, anything. Okay, which is running on user's device, from where they want to upload some kind of media. Okay, this media can be anything. It can be picture, PDF file, video file, anything. And then we have a backend service where all the business logic is written. Okay, and it is exposing some set of APIs to the client with the help of API gateway. API gateway is just a layer which sits between the client and backend service. Okay, and the client makes API calls to this API gateway, and this API gateway then routes the request to different backend services. In our case, we have only one backend service, but there can be multiple backend services, uh, commonly known as microservices. Okay, where this API gateway will route the requests as per the request coming from the client. So we have this backend service. We have a database. This database can be any database of your choice. It can be a PostgreSQL, it can be MongoDB, or any database of your choice. For simplicity, we are assuming that this is a PostgreSQL database, and we will design some tables to handle our use case. Okay, so these are the main components which every system has: client, server, database. These are the normal, usual components of a system. But then we will have some special components here to handle the media handling part. So we will have some kind of object storage. I'll talk about that in detail further. So this is Amazon Simple Storage S3, and we also have this Amazon CloudFront. These two things we will learn about in detail further, and we also have AWS Lambda. Okay, so these are different components which we have in our system. Now let's come to the problem. Now the problem is that as a user, I want to upload some media file using the website or mobile application, that is the client. Okay. Now, in the traditional system, what used to happen is that if we want to allow users to upload media, we will have some kind of API endpoint, let's say uploads only, okay, where the user can like upload a media file in the client, and the client will send the media file in that same API call itself as form data. And then this media file will end up in this backend service, and then the backend service used to store these media files either in the database or in the local file system itself. Okay. And then it will respond back to the client that okay, the media file is uploaded. So it was mainly this backend service which used to like handle the media handling part, and there was one single API call in which the form data in which in the form data the media file was used to send. But this system has its own problems. Okay, your backend service will need to like handle a lot of media files, but let's assume you have a monolithic backend service where you, apart from the media handling part, you're also like managing other business logic. If it is YouTube, then also like you're handling, let's say, subscription APIs. You have like video views, likes, counts, all of these things, different APIs are there, and it is also handling large amount of media uploads, handling all of those media files. And if we are doing that way, then this backend service, it will easily like cross its limit, because it is not designed to handle large amount of media files. Okay. So we'll have some kind of like bottleneck there if we are handling it in our backend. And also you are sending this media file along with your uploads endpoint through this API gateway. And in today's times, most of these API gateways, they have limitation on how much payload you can send in your API calls. So there are different gateways. Let's say AWS also offers different kind of API gateways, and most of the time they will have certain limits. Let's say 20 MB, 30 MB, and max. Above that, you cannot send any payload to your backend. So that is obviously a bottleneck, that you cannot send media files uh, in your API calls directly to your backend. First thing is that, and the second thing is that this backend service, it has its own limitation. It should focus on business logic rather than doing computational heavy tasks like handling media files, then processing them, then storing it in local files. Okay, that is one part of the problem. Other part of the problem is that it was being stored in the local file system, let's say, or database. So database is not optimized for handling media files. Okay. It is not like designed specifically for handling media files. So that is kind of an anti-pattern. Although you can store it in the database, but that is not a good practice. Okay. Second thing is, if you're storing it in local file system, that is also not a good practice, because with distributed system, it will be stored in your local one instance of the backend service. But what if we want to have multiple copies of this backend service? Then this thing will not scale well, and storing it in local file system is not like reliable thing. Okay, if this backend service goes down, then all of those media files can also get lost, and that is not good for our business use case. So we want some kind of dedicated storage service where where we can store these media files reliably, and it should also be durable. Okay, it should be fault tolerant. So for that particular use case, we have this special class of storage which we call object storage. And Amazon S3, which is simple storage service, is a very standard object storage, and it is like industry standard. It is used at a lot of places. There are other alternatives also. If you go to other cloud providers, they will also offer you similar object storage, which are purposely they are designed for handling this particular use case of handling media services. You can store your media over there, and you can distribute from there, and it has like a lot of other features which help us in handling media files, which we will see further. So let's say we are using Amazon Simple Storage S3 for storing our media files. Okay. So this traditional system where we are sending the media file from the same endpoint is not a good way to handle media services. Okay. So we need to think of some modern approach, some scalable approach, some reliable approach, which we can use for handling media files. So one thing we decided that, okay, instead of storing it in local file system or database, we will store it in Amazon S3. Okay, and object storage. Okay, fine, let's store it there. But how do we store it? How do we make this new pattern work in our system? Okay, that is the main question. So before going into there, let's talk about database. Okay, one thing we have finalized is that we will be storing it in Amazon storage, a simple storage service S3. But then we need some information about the media files which we are handling. So we will have a kind of record in our database. So in database, we can create a table called media, okay, which will keep a record of all the media files which our system is dealing with. So in media table, let's say we have an ID field, which will be a unique identifier for that media. And then we can have a MIME type, which can store the media file format. And then we can have the size of that media file. And then we can have a key. The key is nothing, but it is a unique key in object storage. So when you store any media file in this object storage S3, it will have a unique name. Two media files cannot have the same name, obviously, right? So they will have a unique identifier in this object storage, and that is normally called as key. So we will also store that key so that we can identify a media in the object storage by using its key. Okay, and then we will maintain a status. This status will be like pending, uploaded, or processed. Like pending is when this image or media file is yet to be uploaded. It is in the process of uploading, and once it is uploaded in the object storage, we will update its status to uploaded. And then finally, once it is processed, if we are doing some additional processing, then we will update its status to processed. And then when it was created, when it was updated, and who actually uploaded this media file by using this created by field. Okay, and then in other tables, other relations, like let's say it is a profile picture. So in user table, we can have a profile picture field, and we can reference by using foreign key to this media.id. Okay, we can just use this media now anywhere in our system. Let's say this same media we want to use in profile picture, and we also want to use the same media in cover picture. So using the same media, we can like update this id in user like cover picture field also. So that is another like advantage of using such a like system, because in this particular pattern we are uploading media once, and we can like reference it at anywhere, whenever, like wherever you want to use the same media file, we can use it in our database. Okay, so these are the two main tables, or basically one main table to keep a record of the media file, and then we can reference it in other tables or relations as we want it. So this is regarding the tables in the database. Now coming to the main part, let's start the journey of the media file in this new architectural pattern. Let's say our client, which may be a website or a mobile app, the user wants to upload a media file, let's say the profile picture. So as soon as they want to upload a media file, they will click some button, let's say upload media. And when they click on upload media, they select the media file. The client will know that what kind of media file the user is trying to upload. They will extract the metadata of that media file. Let's say it's name, the size of the media file, the MIME type, etc. And then using all of that information for that particular media file, it will invoke this API endpoint that is slash uploads. It can be anything, but for our use case, let's say our backend service expose an endpoint, a post request uploads, where the client can send the media metadata, okay, the size, file name, MIME type, along with some user authentication token. We are not adding it in the body, but it will be added in the authentication header, okay, from where the backend can know that who is the user who is making this API call. And from there, we can extract the user ID. Okay, so once your client send this up media metadata in this uploads post API call, it will go through your API gateway. It will end up in your backend service. Then your backend service will analyze this input data from front end regarding that media file. It will first validate that, okay, what is the size of this media file which the user is trying to upload, what is the MIME type, and it will validate whether this size confirm, like it confirms with the allowed size for this media file. Because if your system uh, here you can put a check like only uploads are allowed till 20 MB or 30 MB or 1 GB. So if the client is trying to upload a size greater than that, you can throw an error back to the client. Okay. And if everything is good, the size is good, the allowed MIME type is good, okay, everything is good, the user is authenticated, the user is allowed to upload, you put all those validation first. And once all of those validation passes, what you will do, you will create a pre-signed URL. You will create a pre-signed URL, and along with that, you will also create an entry in your database. Okay, so you will create an entry in your database for that particular media. You will create one ID, MIME type, size as the front end sent you. You will also create some unique key, and a status will be pending, created at, updated at, and created by with the user ID who made this API call. Okay, so once this record is created in the database, your database now has a record for the media which is yet to be uploaded. Okay, and after that, your backend service will create a pre-signed URL. This pre-signed URL is very important thing here. Pre-signed URL is nothing but it's a kind of like permission to your front end with some special URL, which gives permission to your front end that okay, now you can upload this file using this URL, and this URL will have some expiry duration. Let's say 1 minute. So after 1 minute, you will not be allowed to upload even if you use the same URL. It will get expired after 1 minute or whatever expiry duration you set. Okay, so this pre-signed URL is some special URL which your backend will generate with the help of that metadata, and it will also have some information regarding the file which is to be uploaded. Let's say it's key, and that pre-signed URL will be generated and it will be sent back to your front end in response to this uploads API call. Okay, so your front end sent uploads the media metadata in this uploads endpoint when the user wanted to upload this media file, and in response it got back a pre-signed URL. Now using this pre-signed URL, your front end will try to upload the media file directly to this object storage. So the special property of this pre-signed URL is that it allows your client to directly upload the media file to your object storage. So here we are having lots of advantages here. First is that you're not sending this media file to your backend as it used to happen in traditional pattern. Okay, so your backend is saved from doing that extra computational task for handling that media file, and it can better focus on the business logic. Second, we are directly uploading to this object storage. So it is a much optimized way of uploading, because this particular S3, as I told you, that it is especially like purposefully designed for handling media files. And when you are uploading from pre-signed URL, you get all the goodness of efficiency and faster uploads. So you're directly uploading it to S3, it is much faster, and you're also saving on computation. So this is one advantage. So once you will upload using this pre-signed URL, you will get a 200 response back, and your client knows that okay, this media file is now uploaded, and then you can proceed further with other API calls. You can tell the your user that okay, your file is now uploaded. Okay, so that ends the upload part of the media, but the story doesn't end there. Once the media file is uploaded to S3, how your backend service or how your database will know that this media file is uploaded? Okay, because your status is still in pending. You don't know whether this media file is uploaded in that object storage because it's a decoupled system. Your backend doesn't know that this file exists in object storage S3. Okay, so the status is not yet updated. So how do we make use of that media file? Okay, one thing is that your client can tell your backend that okay, we have uploaded this media file. Okay, when it gets a 200 response from put request, but that is not a reliable way. Let's say your client uploaded this media file in S3, but it lost internet connection. It was not able to make that success call to the backend to tell backend that okay, this media file was uploaded. So that will break the system. That is unreliable system. So we should not rely on the client. Okay. Instead of that, this S3 has another property that is called trigger or notifications. Okay. So you see, like this S3, this thing is very well designed for handling all the use cases of media handling. And that is why it offers this another feature, trigger or notifications. So what we can do is whenever a media file is uploaded in this S3, we can set up a trigger that whenever a new media file appears in S3, we can invoke some other service. We can send a notification message to another service, and then they can do some task. So let's say we set up a trigger called uploaded. Okay, so whenever a file gets uploaded in S3, we send a message to our backend service. Okay, and then our backend service will get all the details of that media file which was uploaded. And since our backend knows that, okay, backend can identify that media file using the key, okay, because it generated that key and the same key exists in the S3 storage. So using that unique identifier key, it can identify that media from database and it can update its status to uploaded, because we are getting a notification in uploaded trigger. That means the file is successfully uploaded. So it can update the status to uploaded, which means that the file is successfully uploaded to S3 and now we can make use of it. If we want to like serve it to the client using some URL, we can do that because the file exists in S3. Okay, so that is one thing. And that will complete this loop of uploading the media file. Okay, but then there can be additional use cases. Let's say YouTube. If you have ever uploaded media files to YouTube, you know that once it is uploaded, it is not yet ready to be like shared with your subscribers. After you upload a video to YouTube, it gets uploaded first and then it starts processing it, because let's say I uploaded 100 GB of video, then YouTube cannot just store 100 GB of video and start sharing that 100 GB of video. It will do some kind of like transformation. It will convert it into different kind of media formats or resolution sizes, 180p, 4K, 720p, right? So that you can view it in different kind of resolution sizes. Okay, that kind of processing happens. So it is up to you that whether you want to process this media file or not. Okay, this is an additional process which you can perform. Now what I suggest is we should always process the media files. We should always do some checks on the media files, because this media files are coming from users. So what processing we can do? We can process it, we can scan it for some malicious like data. Okay, because someone can like upload some malicious data in let's say in form of image, and it can like break our system. So we can like kind of like do that particular check there, or we can convert it into some common file format. So that is another good practice. Like if you're designing a large system, then you should always have a particular file format in which you are going to serve your media files. Let's say images are best viewed on websites in WebP format. So if users can upload files in any format, like you, even if you can put restrictions, but they can upload in different formats, and it is your responsibility to convert those files into one common format so that you can handle them like uniformly. Okay, your clients can have a unified experience that, okay, this is the file format which we are receiving from the backend, and we can optimize the experience for that particular file format. So we can do those kind of additional processing in our in after the image or media file is uploaded. We can also transform the media files in different sizes. Okay, so that if someone is on slow network, they can like request a smaller size file. So all of these things come under processing. Okay, so once the file is uploaded, we can have another trigger to some other service, which can be a serverless function, AWS Lambda, or it can be another like backend service. It is up to you what you want to use. In our use case, let's say we are using AWS Lambda. So once the file is uploaded to S3, we will send a notification to AWS Lambda that this particular file is just uploaded. Now AWS Lambda, it will get that file from S3 and then it will start performing all the processing which we have decided. Okay, now this processing is as per your requirement. As I told, you can do whatever you want to do with that particular media file. And once you have done processing it, you can then either update the database directly from this AWS Lambda, or you can send another notification to your backend directly from the Lambda file. Okay, so let's say you can send the notification from AWS Lambda also, or you can upload that file back into S3 and then another you can trigger another notification to your backend service. It is up to you that how you want to send the message or where you want to update the database. But let's say we want to like assign particular tasks to particular services only. So updating the database task we have assigned to this backend service. So we will send a notification to this backend service that this particular file is now completely processed. And then this backend service will again find this media using this key, and then it will update the status to processed. And that will end the complete flow of uploading the media file and processing it. Now, like we have done everything with that media file, what we wanted to do. And now it is ready to be served to the public. Okay. Yeah. So that is there. That ends the complete flow. Now coming to the serving part. Now the media file is uploaded, and now the user wants to see the profile picture or whatever media they have like uploaded. So now instead of like the client will like have some kind of URL using which it can request the media file. Okay, so to serve the media file, we use some kind of CDN in place. So Amazon CloudFront, it is some kind of CDN. CDN is content delivery network. So it has lots of use cases, and in our particular case, it serves two important use cases. One, it serves as a caching data center. Okay, so this CDN is like it helps in caching those media files, because every time the user is requesting that media file, it will be very huge in size, and every time it will make a request to Amazon S3, and it will get the data fresh from Amazon S3, and then it will again start serving it. Instead of that, we can use the CDN layer in front of this S3, and our client can request that media file from Amazon CloudFront. So if it was requested earlier by the same client, it will be like retrieved from the cache. Otherwise, if the cache does not contain that media file, the request will then be routed to this Amazon S3. Okay, so that is one use case of Amazon CloudFront, that it helps us in establishing that caching layer, and that makes the media loading very faster for the clients. Another use case is that we don't want to expose this S3 publicly. Okay, because this is some private data for our our business use case, and we don't want to expose this publicly to users. So we like once we put this Amazon CloudFront in front of this S3, this S3 gets hidden. It is not directly exposed to the public. Okay, that is another use case. The third thing is that we can also put some geo restrictions on the media content. That is some advanced use case. So if you have like ever seen that on Netflix, some shows may be available in some countries, but they are not available in some different countries. So that kind of use case we perform by using Amazon CloudFront. In Amazon CloudFront, you can put those geo restrictions that if the request is coming from this country, don't serve this particular content. All of that thing we can do in Amazon CloudFront. Amazon CloudFront is itself a very uh, it has very vast amount of features, and we can do a lot of tasks there. Maybe in some other video we can talk about that. But this is how you will start serving those media files. And you see we are always using this key when we are like requesting that media file. So using this unique identifier, your CloudFront can request that particular key from the object storage, because key is that unique identifier of the media file in object storage. Okay, so this is the entire flow of how we can allow uploads from the client to the backend, large media files, and then we can start serving those to the client. So this is a fairly a standard practice which we follow. And then there are few tips which I would like to share. Let's say I will give you one example. Let's say as a user, I open some website, I upload my picture, but I don't continue further. Okay, I don't it was a large form. After uploading the picture, I had to do a lot of other entries, but I uploaded the picture, but I did not submit the entire form. So that picture, it will be lying abundant in the object storage, because that picture was uploaded in the storage, but it was not linked to any resource. Okay, so if that is the case, and that happens a lot, people upload pictures, but then it is not linked to any other resource. So in that case, we can have a temporary bucket where we allow uploads directly from the user. So when the first time user is uploading any media file, it will go to that temporary storage. Let's say we have another bucket which is like a temporary bucket. Okay, and in this temporary bucket, the files will be uploaded first, and then once it is processed completely, then we will move that particular file from that temporary bucket to this permanent bucket. Okay, and on a periodic cycle, let's say a week or after 3-4 days, we will keep on checking this temporary bucket, and we will be deleting the files which are older than, let's say, 7 days or 3 days. Okay, and we are confident that okay, this media file is lying abundant. So that will also help us in reducing our storage charges. Otherwise, people will just start uploading everything, and it is not being used, and it will increase our data charges also. So that is one tip which I wanted to share. And also it is a good practice to have different buckets for processed image, for uploads image. Okay, because you have lots of triggers implemented here. Okay, what that means is like, let's say you have only one bucket and you are saying that whenever a file is uploaded here, you are invoking a trigger to backend service. So let's say you uploaded a file here in this bucket, okay, and then this uploaded trigger will go to backend. Then your AWS Lambda, it will like process that image, and it will again upload that file back into this S3, and then again uploaded trigger will happen. So it will be kind of an infinite loop which will be created there. Like whenever the same file is being uploaded to S3, after processing, the same trigger will keep on uh, triggering. Okay, and then again this Lambda and backend service, they will be running an infinite loop. So it is always just like good practice to have different buckets if you have like this kind of triggers set on your bucket. Okay, so that is one tip which I wanted to share. Other important tip is chunking. I gave you example of YouTube, and in YouTube we upload like a very large size of media files which are in GBs. So if you are like, let's say you are uploading a file size of in GB, and after uploading 100 MBs or 200 MBs, your internet went off. Your like internet got disrupted, and your upload part was just cancelled there, and then you will have to start everything from zero. And you can think of like it's a 100 GB of file, so it will take a lot of time, and there is no reliability in connection, there is no reliability in the process. Okay, as an engineer, we have to think of ways that how to like handle this particular use case. So chunking will help us in this particular scenario. Chunking means that if you have this media file which is of 100 GBs, okay, so what you will do is like you will split this file into different chunks. Okay, you can create like a lot of chunks of this media file. uh, okay, so let's say it is 100 GB of file, so you can like your client can chunk this media file into multiple small file sizes of 100 MB each. Okay, so there will be like lots of files now to be uploaded instead of one single file. So this is called chunking. And now your client will start uploading these media files one by one. Okay, and every time it uploads one chunk, it will basically update your backend that okay, this chunk was updated. And then as soon as it uploads a chunk, it tells your backend, or the backend has a way to know that this chunk was uploaded. Okay, so in that case, even if your upload gets disrupted after 100 MB or 200 MB, and you start sending your whole file again, so you will your backend will know, it has that record that okay, this chunk was already uploaded. So your client will know, okay, this chunk was already uploaded, so I don't need to upload that chunk. Okay, so in that way, this chunking will help you to handle media files of large sizes and in a resumable manner. Okay, you can resume the upload if it was disrupted. So YouTube follows that approach. It does not upload a single file at once. It does that chunking, and then it allows the upload of that chunking. If you ever go to the network calls of YouTube by debugging the console, you will see that it is continuously uploading different chunks of that media file. And then in the object storage, it is receiving those small chunks, and then it will combine all those chunks into one single media file, and that is one media file which will be there in S3. Okay, and also it will maintain different chunks together when it is serving that media file, because on YouTube, when you are viewing content like 4K content of large media sizes, it is not like it gets one big video file at once. It is receiving those media files in different chunks. So that is how this chunking helps when we are dealing with large media files, and that is why this concept of chunking becomes very useful when you are dealing with large media files. Okay, it is not standard when you are dealing with small media files, but it is one non-negotiable like technique which we should follow if we are building something like YouTube, or a system where we're dealing with large size media files. Okay, so these are all the concepts I think which can help you design a scalable and reliable media service, and this is how you should handle your media handling in your system architecture. Okay, it is well decoupled, and it uses a very robust and reliable way of storing the media files, serving those media files. Okay, and scaling up the system if your system requires. Okay, so this is all for this video. I hope I was able to explain you everything regarding media handling and large systems in a reliable and scalable manner. And we'll talk about some other details in some other video, let's say CloudFront or any other topic. And if you have any doubts, you can share your doubts in the comment section. I'll try my best to answer those. Have a nice day. Thank you.